Assalamualaikum warahmatullahi wabarakatuh. In this video, we will explain about application of truth table in real life. Before we continue, I will introduce our group member. First Aswar, second Adam, third Muhammad Aiman, and lastly me, Danish Aiman.
Today, I'm going to talk about truth table. Truth table are a fundamental part of logic. They help us understand how logical statements work by showing whether a statement is true or false under different conditions. We use truth table to make logical decisions, especially in real-life situations such as problem solving and decision making. Truth tables are also very important in computer system and programming because computers use logic to decide what action to perform. By using truth table, we can clearly see how different inputs affect the final result.
Hi, my name is Danish Aiman. I will continue to the topic, which is why this topic is important. I also will explain the points that becomes our objective. Well, logic is the backbone of clear thinking. It allows us to show all possible outcomes of a situation clearly and help us avoid confusion when making complex decisions. Beyond just philosophy, these concepts are the fundamentals building blocks used in software, logic, and computer algorithms. By the end of this session, you will see how logic helps us analyze any condition to determine if it supplies true or false. Let's define some key terms we'll be using. First, a proposition. This is any simple statement that can be declared either true or false. Logical equivalence. We say two statements are equivalent if they produce the exact same true values in every single row of truth table. The conditionals. Expressed as P implies Q, this is your classic if-then statement. The contrapositive. This is written as not Q implies not P. It is a very powerful tool because a contrapositive is always logically equivalent to its original conditional statement. Now, let's look at the math of logic, the symbols. There are four symbols, which is conjunction, disjunction, implication, pin conditional, and negations. These symbols allow us to connect propositions to create complex argument. First is conjunction. This represents the word and. For a conjunction to be true, both statements must be true. Second is disjunction. This represents or is true if at least one statement is true. Third is implication. This is the implied symbol used for conditional statement like if A, then B. The fourth is conditional. This means if and only if. It requires both sides to have the same true value. Lastly, negation. We have not, which simply flips the true value of a statement.
Hi, my name is Aiman, and I will be explaining how we apply truth table to a real-life scenario involving an online learning attendance system. In this system, we have two main propositions, which is P represent the student attends the class and Q represent the student is marked present. The main rule that has been programmed into the system is a conditional statement, which is if a student attends the class, then they are marked present. This is the logical condition for the system. So, we need to ensure that this rule is consistent and any rephrasing of the rule doesn't change its meaning. Now, to analyze this rule deeper, we look at its related statements. Specifically, we focus on the contrapositive. The contrapositive is formed by negating both propositions and switching their order, resulting in if a student is not marked present, then they did not attend. In system programming, we often look for logical equivalence. we need to know if the system can use this reverse logic to catch errors or verify data without changing the actual attendance policy. If the original rule and the contrapositive are equivalent, then the system remains fair and mathematically sound. The truth table is the mathematical proof of that equivalence. Let's look at the results. In the first row, if a student attends and is not present, the rule is true. In the second row, if a student attends but is not marked present, the rule is false because the system failed to follow the rule. In the final rows, if the students didn't attend, the rule remains true because no violation occurred. Now, if we compare the column for our original rule, which is P implement Q, with the contrapositive, not Q, implement not P, we will see they are identical in every single row. They both result in true, false, true, true. This proves they are logical equivalent. This means the attendance system can check if the condition and still get the same result. It ensures that the logic is watertight and there are no contradictions in the software. And that's all. This concludes my part. Thank you.
Hi, and Assalamualaikum warahmatullahi wabarakatuh. And my name is Adam Haris Bezanorin. Today, I will show you guys one example question about the truth tables. So, without further ado, let's get into it. All right, so here is the question. Construct the truth table for the following compound proposition, which is P or negation Q implies Q and R. It sounds like it's very hard, but it is actually very easy. The secret is we break it into pieces. I call it as chunk. The first chunk, which is chunk A, will be P or negation Q. The second chunk, which is chunk B, will be Q and R. So let's take a look at our first three column. It will be P, Q, and R for our setup. So the P will be true, 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 false, 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 false. And Q will be true, true, false, false, true, true, false, false. And the R will be true, false, true, false, true, false. And then let's take a look at the fourth column. When the Q is true, in negation is false. Negation is basically the opposite of the Q. If it is true, then it will be false. If it is false, then it will be true. And then let's take a look at our final result. But first thing first, we need to take a look at the chunk A and chunk B. If the promise, which is chunk A, is true, but the result, which is B, is false, then the promise is broken. That's a false. You can see this happening in row 2, 3, and 4. We had true in column A but false in column B. So the result will be false. So if you take a look at row 6, for example, even though P was false, our result is still true. This table proves exactly when this logic holds up and exactly when it fails. So that's all from me. Thank you so much.
To summarize our lesson, we explore several important concepts in logic. First, we learn about logical equivalent, which means two statements always have the same truth value even if they look different. Next, we discuss the converse, which is formed by swapping the hypothesis and the conclusion of statement. Then, we learn about the inverse, which negate both parts of the statement. We also study the contrapositive, which both swap and negates the statement. This is important because a statement and its contrapositive are always logically equivalent. Lastly, we talk about logical implication, which is show how one statement leads to another. If the first statement is true, then second statement must also be true according to the truth table. In conclusion, the truth table helps us understand logical relationship clearly and very useful in mathematical logic and computer programming.